For question number 26, part B, it says that the function is defined from R to R. So this function has domain as R and codomain as R from real to real numbers. So this function is defined from real to real numbers. This is our input X and this is our output Y. And the function is mapped as f of X is equal to ax plus b. It's also given that, so we have to find the function first. It's given that f of 1 is 1. So how do we find f of 1? So f of 1 means we have to put x as 1. So this is the function given to us. So let's put x is equal to 1, which gives a into 1 plus b, which is a plus b. So f of 1 is a plus b is equal to 1, which gives us equation 1. And also it's given f of 2 is equal to 3. So if I replace x with 2 in this function, so this would be equal to, let's replace x with 2. So this is equal to 2a plus b is equal to 3. This is equation 2. So if I go ahead and add 1 and 2, which gives me a plus b is equal to 1, 2a plus b is equal to 3. And if I subtract these two equations, so this gets cancelled. Now this is negative a is equal to negative 2, which gives us a is equal to 2. And from first equation, that is a plus b is equal to 1, this gives a is 2, so 2 plus b is equal to 1, which gives me b is equal to 1 minus 2 and b is equal to negative 1. So let's replace the value of a and b in the function. So the function was f of x is equal to ax plus b. Now our function is f of x, a is 2, b is negative 1, so 2a, sorry, we have got the value of a is 2, so 2x minus 1 is the function. So this is the function. Now we have to check whether the function is 1, 1 and onto 1, 1. So for function 1, 1, we know that the function is 1, 1 when for every x there is a unique y. So let's say we have x1 and x2. So x1 and x2 that belongs to R, that is domain. So we have to show that. So we have two elements here, x1 and x2, and x1 and x2. So x1 has image, let's say fx1 will have image, and x2 will have image fx2. So we have to show that for every x there is a unique y. But let's consider it other way. Let's say these two are equal. So if these two are equal, and if these two remain not equal, that is x1 and x2 are too different, then that means for these two there is a one image. For then we can say that the function is not 1, 1. So let's say the images are equal, that f1 is equal to f of x. So f of x1 would be 2x1 minus 1, f of x2 would be 2x2 minus 1. Okay, now this gets cancelled and we are left with 2x1 is equal to 2x2. So 2 and 2 gets cancelled. So x1 is equal to x2. So that means if the images are equal, then the three images are also same. So that means these are not two different, but these are also equal. So for every x, there is a value y in the codomain. So that means there is a unique y in the codomain. So that means the function is 1, 1. So this function is 1, 1. And let's prove it for onto. So onto means that all the elements in y should be linked to an element in, there should be a unique element for every y. For y1 there should be an x1. For y2 there should be an x2. there should be no element left here that is not mapped to a certain value in this function in the domain. So our function is f of x is equal to 2x minus 1. F of x means y. So is equal to 2x minus 1. Let's get the value of x. So x. So we have to prove that for every y there is an x. So I'm going to replace x with its value. So x is equal to, this is now y plus 1 by 2. So let's find it for y plus 1 by 2 here. So this is 2 into y plus 1 by 2 minus 1. This gets cancelled. So I have replaced this value of x here, which gives me y plus 1 minus 1, which is equal to that. So that means for every y that belongs to R that is codomain, there exists x that belongs to R that is domain such that f of x is equal to 2x minus 1. So that means the function is on. So this function is 1, 1, and this function is 1, 2. So